Hi, board. Okay, through this video, I'll be discussing the 2019 quadratic equation and the polynomials question in the PO paper. Because before uploading this video, we know that A-level has been postponed by just a month. That like some of the students were expecting that A-level will be postponed like by 2-3 months, but unfortunately, A-levels have already been postponed by one month. So if you don't have a plan how to do this, how to work during these 3 months, these 87 to 85 days, if you're watching this video, like there's around somewhere around 80 days. If you don't have a plan, I have uploaded a video before this video, and just watch it, and then you can get a rough plan and work according to that. And I can be 100% sure that if you are targeting somewhere a result like 3 C's, after executing that plan, you can go for like minimum of 1A, 2B's, like you can increase your results, but you have to do that plan according to the way I have mentioned in it. So I'll be doing the question, the quadratic equation question, and when talking about this question, I know in the PO paper there are like 3 questions mainly that we can save our time, because we know that we are given 180 minutes to do the PO paper. Out of the 180 minutes, normally it takes about 40 minutes to do the first part, 40 to 45 minutes. So if you take 40 to the first part, which means we have 140 to do the second part, and we have to complete 5 questions. 140 divided by 5 will give us 28 minutes. So roughly we get 28 minutes for a second part question. But I know if I do the coordinate geometry question, which means straight line and the circle question, it takes more than 28 minutes. So there are some questions which we can use to save our time, and quadratic equation and the polynomial one is one of them. In some years, they have given us some tough questions to the quadratic equation. If the question is tough, it will take around 25 minutes. But according to this question is easy. Like when considering about the quadratic equation and the polynomials question, considering about the past 10 years, like I can tell this was like the most easiest question, the quadratic equation one and the polynomial question. So in this one, we can just do this around in a time like 20 minutes, and we can save the time by 8 minutes. And then we have the integration part. In the integration question, normally we can save time, and the other one is the series one. If we decide to do the series and the combination permutation question, normally it takes around 20 minutes for that 12 question. So I'll be doing this quadratic equation one, and they have given us, show that. Now you can see the question on the board. I'm displaying the question. If you don't have the question, you can pause the video and write it down. And I'm given the show that 1 is not a root of the equation, and they have given us a quadratic equation, p squared x squared plus 2x plus p is equal to 0. And they're asking us to show that show that 1 is not a root. I know if one is a root, if you substitute 1 for this x, then the equation should be satisfied. The equation should be satisfied, which means the equation should be equal to 0. But they're asking us to show that 1 is not a root. So I'll take in the left hand side. I'll take the left hand side and I'm substituting 1. I get p squared into, right, when x equals 1. Or p squared into 1 squared plus 2 into 1 plus p. Don't write that this is equal to 0, okay? Because I'm going to show that this is not equal to 0. Even though this is equal to 0, we can't write it like here. Like I have to simplify this and show that if it is equal to 0, I have to simplify and show that this is equal to 0. Okay? I'm taking the left hand side and I substituted 1, and I get 1 squared means 1, which means p squared plus p plus 2. It is clear they have given us that p is between 1 and 0, which means p squared is positive, p is positive, and 2 is positive, which means the addition is positive. So when x is equal to 1, the equation is not satisfied. So we can write, therefore x is not a root. We can write this, because if x equals 1 is a root, I know the equation should be satisfied. So I'll move to the second part. They have given us let alpha and beta be the roots of this equation. They have given us the roots of this equation as alpha and beta. And they are asking us to show. Yeah, they're asking us to show that alpha and beta are both real. Show that alpha and beta are both real. So I know when considering to show that the roots are real, I have to consider the discriminant of the equation. I have to consider the discriminant. So let's take the discriminant, and if the discriminant is greater than 0, we can say that it has 2 real roots. And if the discriminant is equal to 0, we can say it has 1 real root. And if the discriminant is less than 0, which is negative, we can say that this equation doesn't have real roots. Okay, this equation doesn't have real roots. So I'm considering the discriminant, which means delta x is equal to b squared. B squared is here 2 squared minus 4ac, 4a, 4, and a is p squared into c. C is p. C is p. So the delta x is equal 2 squared is 4 minus 4p cube, and delta x is equal to, I'm taking 4 out, I get 1 minus p cube. I know the difference of 2 cubes, 1 minus p cube, can be expanded as 1 minus p, times 1 plus p square. This is the expansion of difference of 2 squares, difference of 2 squares, 2 cubes. This is the difference of 2 cubes. It can be expanded in this manner. So it is clear this is positive because p is positive, which means p squared positive, p is positive, and 1 is positive, which means this is greater than 0. And it is clear this one, 1 minus p. They have given us that p is less than 1. Which means 1 minus p is greater or equal to 0. They have given us p is less than or equal to 1, which means 1 minus p. If I take p to the other side, 1 minus p is greater than 0. 1 minus p is greater than 0. So it is clear that the discriminant delta x is greater or equal to 0. So I can write therefore alpha and beta are real. I can write alpha and beta are real. Okay, now they are asking us to show that first we have to write terms for alpha plus beta and alpha beta in terms of p. It is clear. If the roots are given as alpha and beta, the addition of the two roots, alpha plus beta can be written as minus b over a. Minus b means here minus 2 over a is p squared. And they have given us asking us to write alpha beta. The product of the two roots is given by c over a. C is p over p squared, and I get 1 over p. They were asking to write alpha plus beta and alpha beta in terms of p. So I get alpha plus beta is equal to minus 2 over p squared, and alpha beta is equal to 1 over p. Alpha beta is equal to 1 over p. Okay. And they are asking us to show that this one. So I'm taking the left hand side. Oh, I'm just writing this and I'm simplifying this. 1 over alpha minus 1 into 1 over beta minus 1. So I can write it is equal to, this one is equal to 1 over alpha minus 1 into beta minus 1. 1 over, when I simplify alpha into beta, alpha beta, alpha into minus 1 minus alpha, minus 1 into beta minus beta, minus 1 into minus 1 plus 1. Plus 1, it is equals 1 over alpha beta. I'm taking minus out, I get alpha plus beta plus 1. And is equal to 1 over alpha beta means 1 over p, alpha plus beta is minus 2 over p squared, which means minus alpha plus beta is equal to plus 2 over p squared plus 1. I'm multiplying the numerator and denominator by p squared. I'm multiplying the numerator and the denominator by p squared, which means I get here p squared. And when I multiply this by p squared, gets p. When I multiply this by p squared is plus 2. When I multiply this by p squared is p p squared. Look again. I'm multiplying the numerator and the denominator by p squared, which means 1 into p squared means p squared. This 1 into p squared is p. This into p squared cut off and gives us 2. And this 1 into p squared is p squared. So they're asking us to show that 1 over alpha minus 1 over beta minus 1 is equal to p squared over p squared plus p plus 2. P squared plus p plus 2. So I can get the answer in that way. So if you want to note down something in our videos, you can just simply pause the video and note it down, because I'm not giving time to note it down. They're asking us to show that also the quadratic equation whose roots are alpha over alpha minus 1 and beta over beta minus 1 is given by this equation, and that both of the roots are positive. We have to show that both of the roots are positive. I know if you ask to build the equation with the roots alpha and beta, if you ask to build the quadratic equation with the roots alpha and beta, we get it as x squared minus addition of the roots x plus product of the roots is equal to 0. This is the basic theorem. This is the basic theorem. If we not the theorem, the theory. If we are asked to build the quadratic equation with roots alpha and beta, we get it as x squared minus addition of 2 roots x plus product of 2 roots. So they're asking us to show that the quadratic equation whose roots are given as follows. So I get it. It's x squared minus the addition of 2 roots alpha over alpha minus 1 plus beta over beta minus 1 times x plus alpha over alpha minus 1 beta over beta minus 1 is equal to 0. So I'm simplifying it. I'm getting x squared minus, I'm taking alpha minus 1, beta minus 1 as the common denominator. I get alpha times beta minus 1 plus beta times alpha minus 1 x, this one is plus alpha into beta is alpha beta over alpha minus 1 beta minus 1 is equal to 0. When I simplify this one, I get alpha beta minus alpha plus alpha beta minus beta over alpha minus 1 beta minus 1 times x plus, I'm writing this as alpha beta into 1 over, alpha minus 1 beta minus 1 is equal to 0. Look, I wrote this as alpha beta into 1 over, because I know I have taken the equation for 1 over alpha minus beta into alpha minus 1 into beta minus 1. I have already taken an equation. I'm simplifying this. I get x squared alpha beta plus alpha beta is 2 alpha beta, and I'm taking a minus out. I get minus alpha plus beta, and I'm here doing the similar thing. 1 over alpha minus 1 beta minus 1 times x plus, and who is alpha beta? Alpha beta is 1 over p. Into 1 over alpha minus 1 beta minus 1 is equal to this one. From this one I'm taking 1 over alpha minus 1 beta minus 1 is equal to p squared over p squared plus p plus 2 is equal to 0, and p cancel off, and I get x squared minus whose 2 times alpha beta, whose alpha means 1 over p, 2 over p, minus alpha plus beta is equal to plus 2 over p squared into, and this one gives us p squared over p squared plus p plus 2 times x plus p over p squared plus p plus 2 is equal to 0. Is equal to 0. So just do this. And now I can get the answer. I'm taking x squared minus, I'm taking a 2 out, and I'm taking p squared as the common denominator. P squared as the common denominator, which means this, I get a p, this one. Because I take p squared as common denominator, this one is multiplied by p, and I'm taking a 2 out, which means this is p plus 1 into p squared over p squared plus p plus 2 times x plus p over p squared plus p plus 2 is equal to 0. Is equal to 0. And it is clear, this cancel off. And I'm multiplying both sides by p squared plus p plus 2. So I get the answer. I get the quadratic equation whose roots are alpha over alpha minus 1 and beta over beta minus 1. I get it as p squared plus p plus 2 times x squared, and here I get minus 2 times p plus 1x, and here plus p. I multiply both sides by p squared plus p plus 2. So they are asking us to get the answer of the equation, to get the quadratic equation whose roots are these two. I get p squared plus p plus 2 x squared minus 2 times p plus 1 x plus p. So I get the answer in this way. And then I'll move into the next part. They are asking us to show that the both roots are real, are positive. I showed that in the previous one I showed that alpha and beta are real, and now they are asking us to show that both roots of this quadratic equation are positive. So I'm taking the roots, like they have given the roots as like this one, I'm just taking as gamma and delta. Okay. Let the roots be gamma delta. Let the roots be gamma delta. Okay, I know when they're asking us to show that the roots are positive, you may think if the roots are positive, the product should be positive. If the roots are positive, that means the product should be equal to, no, if the roots are positive, which means the product of the two roots are positive. It is correct. But you have to think, not only when the roots are positive, we get the product as positive. Because when both roots are negative, if you consider the product of two negative numbers, we get a positive number, which means the product of the roots are positive. So if they are asking us to show that the both roots are positive, I have to show the addition is positive and the product is positive. That the addition is positive when the product is positive. So it is clear. Because showing that the product of the two roots are positive is not sufficient, because when the two roots are even negative, still the product will give us a positive answer. So I took the roots be gamma plus delta, so I can write gamma and delta, gamma plus delta, which means addition is minus b means this becomes plus, equals 2 times p plus 1 over a, and a is given by p squared plus p plus 1. And it is clear p is a positive number, which means this is positive number over positive number is positive. I get the addition is positive, and when I consider the multiplication, the multiplication is given by p over a. A is here is p squared plus p plus 2. Multiplication is p over p squared plus p plus 2, and it is clear p is positive, so this is positive. So I can write, since alpha plus beta, we can write it since, not alpha, gamma plus delta is greater than 0 and gamma delta is greater than 0, therefore both roots are positive. So they are asking us to show that the both roots are positive. I can get the answer in this way. I have to show that both the addition and the product is greater than 0. So I think this is the quadratic equation question of the 2019 paper. It is clear. I'll be moving to the factor theorem, remainder theorem question. So tell me, what is factor theorem, what is remainder theorem? Remainder theorem, that they are giving us like when fx is divided by x minus a, when fx is divided by x minus a, the remainder is fa. Remainder theorem states that when fx is divided by x minus a, the remainder is fa. And the factor theorem says if fa is equal to 0, which means x minus a is a factor, which means x minus a is a factor, or if x minus a is a factor, fa is equal to 0. I know that. And they have given us let c and b be two non-zero real numbers, and they have given us as fx is equal to x cube plus 2x squared minus dx plus cd, and they have given the data. It is given that x minus c is a factor, so I'll be using this. We know by factor theorem, write it by factor theorem. By factor theorem I can write if x minus c is a factor, which means fc is equal to 0. So I get fc is equal to c cube plus 2 times c squared minus dc plus cd is equal to 0. fc means we have to substitute c for x in this equation. So it is clear that minus dc plus dc cutoffs, and I get c cube plus 2c squared is equal to 0. C squared is common, and I get c plus 2 is equal to 0, which means I get two answers. One is c squared is equal to 0, which means c is equal to 0. Another one is c plus 2 is equal to 0, which means 0 is equal minus 2. But they have given us that c and d be two non-zero, but c is not equal to 0. Therefore, the only answer, therefore, c is equal minus 2. And they have given us the remainder of fx, that the remainder of the fx is when fx is divided by x minus d, they have given us the remainder as cd. When fx is divided by x minus d, the remainder is cd. So I can write by remainder theorem, when fx is divided by x minus d, the remainder is given as fd. When x minus d is divided by fx, the remainder is given by fd, and they have given us that the remainder is equal to cd. Which means fd is equal to 0. So fd, we can get fd when we substitute d for x in here. I get d cube plus 2d squared minus d into d plus cd is equal to cd. And it is clear that cd cancel offs, and I get d cube plus 2d squared minus d squared is equal to 0. And I get d squared plus 2d cube plus 2d squared minus d squared is equal to 0. I'm taking d squared out, I get d plus 1. And here also I get two answers. One is d squared is equal to 0, which means d is equal to 0. The other one is d plus 1 is equal to 0, which means d is equal to minus 1. But they have given us that let c and d be two non-zero real numbers, which means but d is not equal to 0. And then I can get, therefore, the only d is equal to minus 1. They are asking us to find the values of c and d. I can get c as minus 2 and d as minus 1. Okay. And they are asking for these values of c and d. For c equals minus 2 and d equals minus 1, find the remainder when fx is divided by x plus 2 square. Fx is divided by fx plus 2 square. I know that this is minus d, right? This is minus d, and we got d as minus 1 times x plus c, and c is minus 2 and d is minus 1, cd is equal to 0. So I get fx as, my fx is x cube plus 2x squared minus minus plus x minus 2 is equal to 0. And they're asking us to divide this by x plus 2 squared and get the remainder. I know x plus 2 squared is equal to x squared plus 2 times 2x means 4x plus 2 squared is 4. So I know if I need to get the remainder of fx, when fx is divided by this one, I can simply use long division method. I can simply use the long division method, and I get x squared, x cube plus 2x squared plus x plus 2 divided by x squared plus 4x plus 4. Now I know what is long division. X cube is divided by x squared, and I get x into x squared is x cube plus 4x squared plus 4x divided by x cube cancel off, and I get 2x squared minus 2x squared minus 4x squared is minus 2x squared, and x minus 4x is minus 3x, and here I get plus 2, and x minus 2 and minus 2x x squared is divided by x squared is minus 2, and we multiply minus 2 into x squared is minus 2x squared minus 2 into minus 8x minus 8, and I get the answers. These two cancel off. Minus 3x minus minus 8x minus 3x minus minus 8x means plus 8x plus 8x minus 3x is 5x, and here I get 2x. 2 minus minus 8 is 2 plus 8, which means 10. So they're asking us the remainder. Therefore, the remainder, this is the remainder, this part is the remainder. Therefore, the remainder is given by 5x plus 10. The remainder is given by 5x plus 10. So it is clear, like the 2019 quadratic equation and polynomials question is a time saving question. And this is the way this 2019 question is done.